Okay, we're going to start on the extra practice that we did yesterday with the first column. We're going to do the second column today. So here we go. We'll do the same thing we did yesterday. Let's look at the ones that are all multiplied, just a list of multiplied. So we'll start with number 13. And we'll do 14. And we'll do, let's see, I think I have room for one more. Let's do 18. Oh, maybe I have room. That's a long one. I'll wait. Okay, so here we go. Number 13. We know that tangent is sine over cosine. They're squared because the tangent's squared. And we know that cosecant is 1 over sine. So what happens? These will cancel, and we're left with 1 over cosine squared. And everybody knows that 1 over cosine is secant. So that problem boiled all the way down to secant squared. Good. All right, let's try this one. Same thing. This is sine over 1. Remember, we cannot do anything with sines and cosines. Cosine is just cosine. But tangent is sine over cosine. And cotangent is cosine over sine. Now notice that these cancel each other out. Why do tangent and cotangent end up canceling each other out? They're reciprocals. And when you multiply reciprocals, like 2 times 1/2, they cancel out. So all we have left here is sine, cosine. Some of you might be thinking, well, if those are always going to cancel out, can I just cancel them out from the beginning? And the answer is absolutely you can, if you notice that. Okay. All right, where am I now? Oh, yeah. I'm ready for number 18, which is a big one. Wow, it is a big one. This is number 18. Here we go. Sine, cosine, sine over cosine, cosine over sine, and 1 over cosine. So just like before, these guys are going to cancel out because they're reciprocals. So right there they are. They're just gone. Now notice, this cosine is going to cancel with this cosine. So it's this one and this one are canceling. Why are they canceling? Because they are also reciprocals. When you multiply reciprocals, they're going to cancel out every single time. So what am I left with here? All I have left is sine. So all that big mess just boiled down to sine. Okay, what was that? 18? All right, let's do 19. And then we have the last one here. Oh no, there's one more, I guess. All right, so here's number 19. So sine squared over 1. 1 over cosine. Now cotangent, that is cosine over sine. And they're squared, of course, because that's squared. So my sine squared are going to be gone. Cosine is going to go into this cosine, and I'm going to be left with cosine. one cosine left when I cancel. All right. Number 21. Sine over cosine. 1 over cosine. 1 over sine. Sines are going to cancel, and it looks like I am left with 2 cosines in the bottom, so 1 over cosine squared. And one more. 23. I think we talked about one like this yesterday, or earlier today actually. And that 3, we're just turning it into a fraction, just like everything else, just 3 over 1. And then we'll have our sine over our cosine. And our cosine squared over our sine squared. Oh, be careful here. That sine is going to cancel with one of these. And that cosine is going to cancel with one of those. So it looks like I'm going to be left with a cosine over a sine. And my 3. What is cosine over sine? We can rewrite that. Cosine over sine is cotangent. So this one boils down to cotangent. So when we take our quiz next class, we will have a problem, one problem on the quiz that is like these that we just practiced. A big long string of multiplication. You are going to rewrite each function in its fraction form and then hopefully cancel a whole bunch of stuff. Now the other question on the quiz, there'll be 2 questions. One will be like this. The other one will be one where you'll have to do some substitution off of your reference sheet. Okay? Now, actually, that's not quite true because number 12 is a little bit different. This one's a little bit different because we are going to go ahead and change this into its fractions. The difference is, do you see it? What is the difference? The difference is this is not a times. If this had been a times, we could cancel. Oh, I don't know what I'm doing there. We could cancel. Cotangent is cosine over sine. We could cancel, but we can't cancel because of the plus. So what do we do when we are adding fractions? This one's a little different. It will not be on your quiz, but it might be on your test. A problem like this. So this part's easy. You know how to change into fractions. Now, how do you add fractions? You get a common denominator. And the common denominator will be sine, cosine. So this fraction needs a sine. This one needs a cosine. And remember, when you put it in the bottom, you have to put it in the top. So now I have one fraction, and that's the denominator. Keep it. Keep the denominator. What's in the numerator? Sine squared plus cosine squared. Oh man, is your heart beating fast? I hope so, because what's sine squared plus cosine squared? 1. So we end up with 1 over sine cosine. So again, that one's a little different because instead of multiplying, we were adding. We still changed into the fraction form, but then we had to get a common denominator. Again, that is not on your quiz, but it might be on your test. All right, so now I'm ready for 15. So this is one where this could be on your quiz. This kind's going to be on your quiz. You have to look at your reference sheet and find something. Let's just look at the numerator for a minute. Find something that might fit with 1 plus tangent squared. Well, shoot, guys, that's right there. What is 1 plus tangent squared? Secant squared. So your numerator is just secant squared. What about your denominator? What's 1 plus cotangent squared? It's right there. You don't have to do anything. It's typed right on the sheet. 1 plus cotangent squared is cosecant squared. Now, we've done a few of them like this. We talked about this. You have something over something. When we have that situation, I like to write it longhand. I'll do it over here so I get it on the video. I like to write it longhand. So I'll write secant squared divided by cosecant squared. Write out the division. This is a division. Now, what is secant squared? Now, I know you can replace it with other things, but what is it in its fraction form? Secant squared is 1 over cosine squared. And I am dividing that by cosecant squared, which is 1 over sine squared. Now I have a fraction divided by a fraction. Keep, change, flip. So 1 over cosine squared times sine squared over 1. Nothing cancels, so I'll just multiply and get sine squared over cosine squared. Uh-oh, you should recognize that. What is sine over cosine? Sine over cosine is tangent. It's squared, so this is tangent squared. So that original problem right there boiled down to tangent squared. Went this way. Boiled down to tangent squared. It's a little harder than some of the others. We've practiced it. All right, how about number 16? Hopefully you recognize the numerator. What is the numerator? 1 minus cosine squared is sine squared. And you're done. That's it. Nothing else cancels. Keep in mind that while you could change cosine squared into 1 minus sine squared, you're still not going to be able to cancel anything because you're still going to have a plus sign in your problem. You can't do anything with that bottom. That bottom isn't anything. So we're finished. That's it for that one. That was an easy one. 17 is easy if you don't let yourself get psyched out by the cube. Kind of ignore the cube for a minute and look at that denominator. What do we know about the denominator? The denominator, 1 minus cosine squared, is sine squared. So the top is sine cubed, and the bottom is sine squared. See, easy, easy, right off your sheet. That's sine squared. So now we have 3 sines over 2 sines, so we're going to cancel these and cancel 2 of those. So our answer is just sine. You have 3 of them over 2 of them. So you have 1 extra on the top, sine. All right, number 20. Well, if you're doing this on another sheet of paper and you wrote that down, hopefully you notice something immediately. What is your denominator? 1. So we have secant squared minus tangent squared. That's all I have right now because this just makes 1. Let's look at our sheet. Doesn't it say somewhere on your sheet that 1 plus tangent squared is secant squared? So I'm going to take this secant squared right here, and since secant squared is the same as 1 plus tangent squared, I'm going to plug that in. So 1 plus tangent squared minus this tangent squared, so this is what I plugged in. Well, 1 plus tangent squared minus tangent squared, those are going to cancel, and by golly, the answer to the problem is 1. One more. This one introduces a little bit of a tricky thing too. Now, not the bottom. The bottom you should know immediately. What is on the bottom? 1 minus cosine squared is sine squared. So the bottom is sine squared. Now the top, okay, there's something wrong with the top. We know, it should be written on your paper, that 1 minus cosine squared is sine squared, and 1 minus sine squared is cosine squared. These are written on your paper. Now be careful because look at your numerator. It looks like I'm going to use this thing right here, but what's the matter? That says sine squared minus 1. My formula says 1 minus sine squared. Those are not the same thing. They're very closely related for sure, but they're not the same thing. I want you to think about this for a second. Are 3 minus 4 and 4 minus 3, are they the same thing? Well, they're the same number, but one of them is negative. In other words, when you subtract in the wrong order, you become negative. When you subtract in the wrong order, you don't get 1, you get negative 1. 5 minus 7. I'm subtracting in the wrong order, and I get negative 2. This problem, is being subtracted in the wrong order. It's supposed to be subtracted like this. Now, I can go ahead and do that, but it's in the wrong order. So instead of getting cosine squared, which is what I should get, I'm going to get negative cosine squared. So if you want to write that on your sheet, you can, that sine squared minus 1 is negative cosine squared. And likewise, cosine squared minus 1 is negative sine squared. Now, I don't know if you want to, I don't know how full your sheet's getting. Just remember that when you subtract backwards of how you're supposed to subtract, your answer is going to be negative. So when I subtracted this in the other direction, I got a negative cosine squared. So anyway, now I got negative cosine over sine. Cosine over sine is cotangent. So this is negative cotangent squared. They're squared, negative cotangent squared. All right, that takes care of that sheet. Let's get out our practice quiz packet. And we're going to do the last one. What will your quiz look like? It will look exactly like the practice. So 2 problems. One of them will be a problem where you have to substitute something in from your sheet, and one will be one of those big long right amount problems. All right, let's look at the first one. 1 minus sine squared over cosine cubed. We are absolutely 100% not frightened of this. You should recognize the numerator. We just talked about it. 1 minus sine squared is on your sheet. 1 minus sine squared is cosine squared. So now you have cosine squared over cosine cubed. You can cancel. And what's going to happen when you cancel? Well, you're going to cancel out 2 of them. So they're all gone from the top, and you have 1 left on the bottom. You have 2 on the top, 3 on the bottom. You're going to cancel them, but there's going to be 1 left over on the bottom. So you end up with 1 over cosine, and everybody knows that 1 over cosine is secant. All right, last one. Good grief. All right, here we go. Do not panic because it's a cubed. You do it exactly the same way. So what's cotangent? Cosine over sine. So this is going to be cosine cubed over sine cubed. Times, all right, here we go, sine squared over 1. Can't do anything with a sine or a cosine. Everything else gets changed, but not sine and cosine. Secant squared, 1 over cosine squared. Tangent, sine over cosine, and then cosine over 1. So change everything into fractions, and then hopefully a bunch of stuff will cancel. So let's see. Look here. Now you can cancel in any order you want, but I happen to notice that right here, what have I got? I've got a cosine squared and a cosine. So won't those 3 cosines cancel those 3? Oh, and look here. I have a sine squared and a sine. Won't those 3 sines cancel these 3? Looks like all I have left is cosine. So that one boils down to just cosine. Next time I see you, we have a quiz. Okay, now let's get out our notes and let's continue our conversation about the law of sines. our notes. 5.1, or excuse me, 5.5, number 2. Notice the directions are different. The directions do not say solve the triangle. The directions say how many triangles are possible. All right, now just hold on. I'm going to draw a picture of this triangle. So here's triangle ABC. This is problem number A, letter A, 2A. Now I remember that angles are big letters, so angle A is 20. Side A, which would be right here, side A is 12. And side B is 31. So 20, angle A is 20, side A is 12, angle B is, I don't know, but side B is 31. Now when I look at this, I very clearly see that pair. And I remember from yesterday that when I see that pair, I'm going to set up my law signs starting with that. So sine 20 over 12 equals sine B over 31. Okay? Now let's cross multiply. 12 sine B equals 31 sine 20. Now I want you to listen very carefully to me. These are glued together. You cannot separate them. So all we can do is divide by 12. So then we have sine B equals 31 sine 20 over 12. I want you to think about, in chapter 4, what we just finished, when we were finding the angle, and we knew this was 12 and this was 15, we wrote an equation that said sine x equals 12 over 15. And then what was I constantly harping at you about? Don't do any arithmetic. Don't multiply by 15. Don't do anything like that. What do I do? What did I do down here? When my job was to find an angle, which is exactly what I'm looking for, when I have to find an angle, I inverse sine or cosine or tangent, whatever it is. So here's the deal. I'm looking for an angle. So I need to inverse sine that fraction. When your variable is an angle, go ahead and get this by itself, but then inverse sine. So you type that in exactly the way I wrote it. You're going to type second sine, and then 31 sine 20, close the parentheses around the 20, divided by 12. And you should get angle B to be 62.07. Boy, that just doesn't make sense, but that's what I got. Is that what you got too? Yeah, okay, we're all right. Okay, now, here is where the tricky part comes. I didn't tell you before, but when the directions say how many triangles are possible, there are 3 possibilities. You could have no triangles, you could have 1 triangle, or you could have 2. We're going to do several examples so you see how this works. But when I typed this in on my calculator, this right here, I got an answer, 62. So that means that there is at least 1 answer. That triangle right there is 1 answer. Now, I need to check to see if there's another answer. So it's very easy. Hang with me. Redraw your triangle from the beginning. So A was 20, side A was 12, side B was 31. Okay. If there is a second answer, okay, I know there's at least 1 because when I typed this in, I got an answer. So I know there's at least 1. If there is a second answer, it will always be 180 minus the first one. So 180 minus 62.07. Did you get 117.93? That works. This is Ford. How do you know it works? Well, remember, the angles of a triangle have to add up to 180. If one of them is 117 and one of them is 20, is there room for a third angle? Yeah, because this only makes 137, so you would have enough degrees left over to have an angle over here. If, let's say this had been 80, then you couldn't have a 117 because 80 and 117 is more than 180. So that wouldn't work if that were 80. But when that's a 20, like it was in our problem, that triangle also works. So how many triangles are possible in this scenario? 2. I know it's confusing. Hang on, we're going to do another problem. All right, let's try the next one. All right, so I'm going to draw the triangle. And this is 76, and this is 18, and this is 20. Now, forget about your confusion. Let's do what you know how to do. You know how to set up the law of sines. So what will it look like? Right here. That's where you start. So sine 76 over 18 equals sine B over 20. So 18 sine B equals 20 sine 76. Now remember, this is glued. So all you can do is divide by 18. So sine B equals 20 sine 76 over 18. Okay, what do we do now? We're trying to figure out angle B. What do we press on our calculator if we want to find an angle? We do inverse sine. Just remember to close that parentheses right there. right, so here we go. Inverse sine 20 sine 76 close parentheses divided by 18. I better type that in again. Second sine 20 sine 76 divided by 18. I keep getting error. Do you keep getting error? What's going on? Remember, when the directions say how many triangles are possible, I could have none, or one, or two. Our first example, we had two. How about this example? None. No triangles possible. Your calculator tells you that. It says, whoa, you can't do that. Error. You can't have a triangle like that. So no triangles are possible. The problem is over. We write down 0 and move on. Here we go. Next. So angle A, side A, angle B, side B. Right there's your match set. So sine 85 over 15 equals sine B over 25. All right, you know what to do. We have it set up. You know what to do now. We're going to cross multiply. Erase some of this other stuff here. We're going to cross multiply, so 25 sine 85 equals 15 sine B. Cross multiply. This can't be separated, so about all I can do is divide by 15. So sine B equals 25 sine 85 over 15. Well, what do I do now? I'm looking for an angle. So I'm going to inverse sine. I'm going to inverse sine. So second, turn on, second sine, 25 sine 85, close parentheses, divided by 15. Did you get an error again? Okay. That's going to happen a third of the time because we have three possible answers. Oh, no solutions, 0. It says how many triangles are possible? None. This is also a none. Okay. That's all right. We got more. Let's try it. Let's see what happens back here. Maybe we'll actually get an answer this time. Let's see. So for problem D, angle A is 42, side A is 22, and side B is 12. Okay, so here we go. Sine 42 over 22 equals sine B over 12. Now we're going to cross multiply. So 22 sine B equals 12 sine 42. This is a unit, so we'll divide by 22. And sine B equals 12 sine 42 over 22. Please do not type in that fraction. That fraction is not the answer. The answer is inverse sine that fraction. Because you are looking for angle B. And in order to find angle B, you have to inverse sine. All right, let's see. Hopefully this one will work. So second sine, 12 sine 42, close parentheses, divided by 22. Oh, I got an answer. My angle B, I got 21.41. All right, so remember now, how many triangles are possible? It's either 0, 1, or 2. Well, I know it isn't 0 because I got an answer. I have an answer. So I know it's either 1 or 2. So now I know for sure I have 1. I'm going to check for the other one. So remember, when we check for the other one, we redraw the triangle. Here's angle B down here. Redraw the given, 42 and 22 and 12. And then figure out if there could be a different angle B. If there is a different angle B, it will always be 180 minus the first one. So since the first one was 21.41, the second one would have to be 158.59. So we did the math, we second signed, and got that angle. If there is a second angle, instead of being 21, it's 180 minus 21. Now, I want you to look at this scenario. Can that be a 158 if that's already a 42? No, because this adds up to more than 180. Can't do it. So that angle won't work. So therefore, there is only one possible triangle. All right, we're going to do one more. I'm going to save the last one for when we're together, but let's do one more, and then we'll call it quits for the day. So here we go. Here's my triangle. A is 60, side A is 9, and side B is 10. Remember, guys, little letters are sides. So sine 60 over 9 equals sine B over 10. So I'll cross multiply. So I get 10 sine 60 equals 9 sine B. Divide by 9. Remember that you cannot separate that. So all you can do is divide by 9. So 10 sine 60 divided by 9 equals sine B. Now I need to find angle B. So remember, if I'm finding the angle, I have to do inverse sine. So here we go. Second sine, 10 sine 60, close parentheses, divided by 9. Did you get an answer? I did too. I got angle B to be 74.21. Now remember guys, you're either going to have no triangles, one triangle, or two triangles. Since you got an answer, you know you have at least one. Remember, the problems that have no answer, what happens on my calculator? I type it all in and I get error. That means no triangles. When you type it all in and you get an answer, that means you're going to have at least one triangle. So then you draw the triangle again, putting the 60 and the 9 and the 10, and you ask yourself, okay, the first angle B I got was 74.2. If there is another triangle, this new angle B, the other possible angle B, will be 180 minus the first one. So let's see what that would be. That would be 105.79. So you're going to set up your law signs, you're going to second sign, and you're going to get an answer. We got 74. Then we're going to check to see if instead of 74, could that angle be 180 minus it? So could that angle be 105? Well, look, over here you got a 60. Is it possible? Is it okay? Is it doable to have a 60 and a 105 in the same triangle? Yes, because what's the rule for triangles? They have to add up to 180. Well, these two only add up to 165. So this would be a tiny little angle for sure, but this is not yet 180, so there's room for a third angle. So that triangle is possible. Therefore, we have another example of two possible triangles. All right, I gotta check my time here. Yep. Okay, well that's enough for today. Can't wait to see you again and hope you have a great Valentine's Day. See you later. Thanks for watching.